So let's just get started with the content. So vectors. So vectors are projectile motion. Vectors are dealt with a lot throughout the entire year, so please do not neglect them. They are something you have to remember because they do end up being worth quite a few marks on the external. So a vector is a quantity defined by a direction and a magnitude. So for instance, say a boat was going east at 10 kilometers an hour. That has not only direction, but it also has magnitude, the direction being east and the magnitude being 10 kilometers an hour. If you were to just say it's going east, then that's not a vector, that's a scalar quantity. So you've got to make sure it has both of those. It's often useful to split up vectors into horizontal and vertical components, and we will have a look at this a bit more when we get into projectile motion. So for instance, to calculate vertical height or horizontal range of a projectile. So as we can see here in the little picture, projectile motion consists of separate horizontal and vertical velocity vectors. These vectors are independent and occurs simultaneously. Simultaneously means at the same time, if you're not so sure. Gravity would only accelerate the vertical component of the motion, whereas horizontal velocity would be constant, assuming that there is no resistance. That is really important to remember, and I will underline that. Assuming no resistance. But assuming is the key word I'm talking about here. Reason being is because when you go through a lot of physics questions, it doesn't necessarily just have to be vectors of projectile motion. You have to remember your assumptions. And it's good to listen, that way you know what variables you do need or don't need. Because what do they say? Oh, air resistance does count or doesn't count. You've got to remember what's important to you answering this question. So they're saying assuming no resistance. This could mean air resistance. So that basically means that either Vx, or in this case maybe Ux, is constant between these parts, because they each have the even number of spaces. They're all the same size, so that means the velocity in the x direction does not change. However, due to gravity, Uy, or Vy, depending on how you look at it, I'm just going to call it Uy, the strength of gravity, that acceleration due to gravity, brings that cannonball closer and closer to the ground faster and faster. So it starts off really weak and then it gets stronger. So you could see that these gaps tend to widen. But yeah, always remember that Ux, or the horizontal component of velocity relatively stays the same, assuming no resistance, whereas vertical velocity changes due to gravity. Alright, now let's get into the formulas that we need. So we've got a few here that we're going to deal with, and I've already kind of talked about a little bit about some of these variables, but we're going to go over what each of them are, because sometimes people see S and they're like, wait, what is that again? Wait, why is it SY? Wait, why is it squared? So I'll go over what each of these formulas are for really quickly. But before I even do that, I just want to say, in physics, at least for the QCE system, gravity is 9.8. It's not 9.81, it's not 9.79, as I've seen in some textbooks, it's 9.8. Just leave it as 9.8. But yeah, so just remember that it's always 9.8, and that's what it says outright in your formula sheet as well, so just stick to that. Okay, to the formulas, so let's look at this first one. So we've got Vy, and Vy is velocity in the y direction, so the vertical direction. And I'm just going to do a little drawing down here. So say something gets thrown up in the air and comes down to land. As you saw on the last slide, I used UX and UI, and there's a reason for that. So I'll show you now. Up until about this point, initial and vertical velocity is signaled by U. So this is initial velocity in the horizontal direction. This is initial velocity in the vertical direction. Oh wait, did I say horizontal for the bottom? Horizontal is UX, UY is vertical. There you go. Sorry if that was confusing, but it's the U stands for like initial velocity. Okay, and then if I get another color, you'll notice throughout this lecture that I love using the different colored markers. Yeah, because then the ball in this scenario reaches a point where velocity in the y direction reaches 0, and then it just starts descending, all in the while when UX or VX stays the same. So now it starts turning the other way after that halfway point. So this is Vy, so that vertical velocity changes its direction. And then we've got that horizontal velocity. Okay, so that's how it works. That's what each of these variables are. So you got UX being initial horizontal, you got UY being initial vertical velocity, you got VY being final velocity that's vertical, and then you got VX, which is final velocity in the horizontal direction. You get the gist. Anyway, it doesn't have to be a very specific name, but that's what that means. So back to this first formula, to calculate the final velocity in the vertical direction, it is equal to gravity times time plus the initial vertical velocity. SY is vertical displacement, and then you know the rest of those variables. Yeah, and then one key thing here to remember that people always tend to forget when doing questions is that Vx is equal to Ux, okay, because that horizontal velocity never changes. And yeah, I'm pretty sure that's it for those. If you have any questions, pop them into the chat if you're not sure about any of these. But just so you know as well, say you've got a variable that you don't know in one, but you can utilize another formula to help you out. Like say you're trying to find Vy, but you don't know Sy, so you got two unknowns. You could always use this one. That was a bad scribble. You know what I mean? To plug it into there, provided you know what time is and what UI is, but you have to know what UI is anyway for this part. So you can really manipulate these formulas to work in favor of what you do or don't have. Alright, so let's get started on some questions. So we've got here an arrow is shot at 40 meters per second at an angle of 45 degrees above level ground. So we're going to do A on this page. Draw a diagram showing the trajectory and initial velocity vector. So, alright. So it gets shot straight up in the air like that. I'm just wondering. I'm going to say it just kind of goes down like that. I know it's really bad, but for this question, all we're really concerned about is it meeting like this point before it starts descending. Yeah, because down here we start talking about maximum height. Actually, I might just redraw that because I'm not too happy with that little drawing. Might just clear the whole page. Cool. Alright. So we're going to say it goes up like that. Alright. Yeah. So we've got 45 degrees. It was shot at. And the initial velocity, so just a u, because they're not giving us a vertical or a horizontal component, is 40 meters per second. Alright. And then this is kind of like the halfway point where it starts going the other way. So we've shown the trajectory. Just put in arrows just in case. And the initial velocity vector. So this is the initial velocity vector here. The one that I draw very poorly. Okay. Now we need to calculate the horizontal and vertical initial velocity of the arrow. So we'll probably do it on this page as well. Call it B. I don't know how to do all the letters. Sorry about that. Okay. So you might be thinking, okay, how on earth do we calculate uy and how on earth do we calculate ux? If you've already started this, then terrific. Put it in the chat and that will be checked. But yeah. So this is being fired, and uy is opposite this angle, okay? This is the hypotenuse, so think of it like trigonometry, SOHCAHTOA, and this is adjacent. So to calculate ux, that's our adjacent, so we're going to be using cos. So cos uh, 45 degrees multiplied, oh not multiplied, sorry, that was a mistake. Cos 45 is equal to ux divided by 40, because that's our hypotenuse. And now we multiply both sides by 40 to get ux by itself, and we are left with a number I need to plug into my calculator, but put it into the chat if you've calculated this. Yep, so cos 45, and also make sure if you're doing methods or specialist and you're using a graphics calculator, make sure it's in degrees, not radians. Yep, so you should have gotten an answer of 28.28. And that's in meters per second because we have to use the same units. Okay, and now it's going to be very similar for uy, but this time we're dealing with opposite and hypotenuse, so we're going to use sine. So sine 45 is equal to, what's her name? Uy over 40. Then once again you multiply both sides, and you will find that uy and ux is the same, 28.28, and that's just because that's the way the math works. We just happen to get both the same answer. And if you wanted to check this and like do some of the Pythagorean theorem, then by all means check, but you will end up with 40 if you were to do so. But yeah, so 28.28, that's ux, and it's also uy. Okay, now using that, we now need to calculate the time of flight of the arrow. So we're going to go over here, see the time of the flight of the arrow. So for this, we are going to need the formula Vy is equal to gt plus uy. Now, because we do not know what Vy is, we are going to say that it is 0, because initially Vy is nothing, all right? And we're just going to use the initial velocities that we have, but our final velocity we do not know. So Vy we don't know, Uy and Ux we do know, but we don't need Ux, we just need Uy. So we're going to put 0 is equal to 9.8 times t plus uy. Oh, and I just want to say as well, this is like an approximate value. I rounded that. So just make sure you get the curly equal signs. Plus uy, which is 28.28. Okay, and then we're going to rearrange, so this is going to be negative 28.28. Which is equal to 9.8t. Now you're probably thinking, hey, we're going to get a negative answer. Well, remember that gravity is actually a negative value, so we're actually going to end up with a positive value. And even if you did end up as a negative value, just negate the negative and just treat it as a positive. But in this case, we know that gravity is normally negative. So negative 28.28 divided by negative 9.8, that's going to be 2.8, I'm going to round it to 2.9 seconds, 2.89 I should say. Always round to 2 decimal places if they don't specify what you need. Alright, next we need the maximum height of the arrow, so we're going to do it on this page as well. So the maximum height. This is where we need, where is it? Yeah, sorry, I was just looking at my little note there. So we've got v squared y is equal to 2g sy. Sy is what we're trying to find because they're saying horizontal range. Oh wait, no it's not. Is this the right formula then? Oh, sorry, I was looking at the very last one. I was meant to be looking at the one above it. Sorry if I just confused you guys. Calculate the maximum height. Yeah, then that's fine. SY is fine, because height is dealing with the Y direction. So we need to find out what that will be. So the reason why we're using this formula, and I'll just say why in a second so I don't get muddled with my words as I write. At the maximum height, uy and vy is equal to 0 at this point. Reason being is because the velocity slows down so much to the point where it comes to a full stop in the air and then it starts to descend. So uy and vy are equal, which is 0. Okay, so this is going to be 0 and this is going to be 0. So let's... Oh, actually, is that fine? Didn't write it in my note. I've just got down here in my note that only Vy is going to be 0. But the thing is, if both of them were to be 0, then you'd find that Sy is going to be 0 in the end, because you can't divide 0 by anything. That puts us in a bit of a pickle. Little bit of a pickle. Just quickly see if there's another way we can figure this out. I think we'll just make Vy 0, because that's what my note said and I didn't write the justification for it. But I think, just thinking about it, I mean, logically Uy would also be 0 at that spot. But it can't be, for the sake of math, so... I think we'll just use the Uy that we have, and then we'll just leave Vy as 0. I think that's what we'll do. Because then we've got 2 times 9.8, and if this is incorrect, then it will be put in the comments. Or you guys can figure it out and then share amongst yourselves. Multiplied by Sy, which is what we're trying to find, plus U squared Y. So that's going to be 28.28 squared. Alright. And then we're going to move this over here, because we need to get Sy by itself. So I'm just going to quickly calculate what that value is. That's going to be 799.75, but that's going to be a negative because we're moving it over. Oh, it's actually be 0.76. And then we've got 2 times 9.8 times Sy. Yep, and we're going to divide the other side by 2 times 9.8. So then we're going to end up with Sy is equal to a number, and that number will be okay, we're thinking here negative 40, but once again, we can't have a negative distance. We're just going to negate the negative. I'm going to say 40.8. So apparently, according to our math, at 40.8 meters high, that displacement, that's when we reach our max height. Now let's do E. All we need for this one is displacement in the x direction is equal to the initial horizontal velocity multiplied by time. And hopefully you guys can read that. So that's just going to be equal to 28.28 multiplied by 2.89. So 2.89. Oh, it's literally right there. Yep, 28. Yeah, 0.28 times 2.89. And this will give us our horizontal displacement. Yeah. Yep. So our horizontal displacement will be 81.73 meters. If you have any questions about this question, feel free to pop them in the chat. Otherwise, we will move on now.